Welcome to qnawire.
Okay, what is meant by nucleophilic substitution? Well, let's just break this down, the words first, and then we'll use, as they said, sodium hydroxide and chloroethane to illustrate. So, first word I see is nucleophile. Well, it's nucleophilic, but we're just focusing on the root word nucleophile. That means it wants electrons. Or, sorry, not wants electrons. It wants a nucleus. It's nucleus loving. Nucleus loving. And nucleus is basically synonymous with positive charge, right? It's a nucleophile is typically either a negatively charged molecule or a molecule that has lone pairs that it can donate to some nucleus somewhere, right? So the nucleophile in this reaction would be our OH minus, right? It's got a negative charge. It wants to go find some nucleus. That's our nucleophile. And what is meant by substitution is that we're going to have some substrate. In this case, it's chloroethane. And our product is going to have the chlorine substituted with our nucleophile, right? Substituted meaning replaced by. So the impetus for the reaction is that we have some nucleophile. And the result of the reaction is that our leaving group will get replaced with that nucleophile. Okay. And so, yeah, in this example, OH is our nucleophile, and the lone pair will attack. Let's draw that a little better. If I get rid of this box, it'll help. There we go. Okay. So our nucleophile, just let me point out one other thing. So consider the carbon-chlorine bond. We know that chlorine is far more electronegative than carbon. So this chlorine is partially negative, and this carbon is partially positive, right? So that's what's attracting the nucleophile to it. It's the nucleophile is seeing this partial positive charge on carbon, and so it's going to attack it, and the chlorine's going to leave, and that's what causes the chlorine to be substituted with our OH. And that's roughly what is meant by nucleophilic substitution.